Hello everyone. In this video we will study third algebraical method to find pair of linear equation into variable, which is cross multiplication method. Okay, in previous videos we have learned substitution method and elimination method to find solution of pair of linear equation. Now in this video we'll study how to find solution of system of two linear equations whose standard forms are this. First equation will be a1x plus b1y plus c1 equals to 0, and second equation will be a2x plus b2y plus c2 equals to 0. This is in the standard form or general form, you can say. Okay, so to solve it by cross multiplication method, what we have to do, we need to write this variables and constant term with some denominator. We have to equate the this variable terms along with some denominator, okay, to constant term along with some denominator. Okay, so see, x equals to y equals to 1. These are the denominators. How we have got this denominator, I'll tell you. See, for denominator of x, variable of x is a1, a2, so leave it. For denominator of x, we will take b1, b2 and c1, c2, b1, b2 and c1, c2. Now for denominator of y, we will take c1, c2 and a1, a2, and for constant term we will take a1, a2 and b1, b2. Here it is. Okay, so see how we'll get denominator of variable x. This is the denominator, no? See, b1, b2, c1, c2. Now we need to cross multiply it. b1 into c2 minus b2 into c1. b1 c2 minus b2 c1 is the denominator of x. Now for y, okay, for denominator of y, see, c1 into a2 multiply c2 into a1. Okay, so c1 into a2 minus c2 into a1. Now for constant term, a1 into b2 minus a2 into b1. Okay, see, plus 1 you will take if and only if this equation is in standard form. If equation is like a1 x plus b1 y equals to c1 and a2 x plus b2 y equals to c2, then this 1 will be minus 1. You will take 1 as minus 1. Okay, and see, for denominator of x, b1, b2, c1, c2 you have taken, no? So this c1 you will take as a first what you can say, coefficient or constant of y. Okay, because see, here x is ending with c1, c2, no? So here for y you will start with c1, c2. Now here denominator of y is ending with a1, a2, no? So for constant term you will start with a1, a2. Okay, after getting this x upon b1 c2 minus b2 c1 is equals to y upon c1 a2 minus c2 a1 is equals to 1 upon a1 b2 minus a2 b1. Okay, after getting this, see, only x and y are the variables or unknowns, you can say. All these values you will get as some constant number. Okay, so when you will compare or equate this term with this constant term, you will get value of x, and when you will compare or equate this term with this constant term, you will get value of y. This will understand by solving some questions of exercise 3.5. okay, see, to understand this cross multiplication method, we will take question number 1 of exercise 3.2 and its second bit. Second bit is 2x plus y is equals to 5 and 3x plus 2y is equals to 8. See, I have told you that to solve this pair of linear equation, we need to arrange this in standard form first. So you will write in standard form as 2x plus y minus 5 equals to 0 and 3x plus 2y minus 8 equals to 0. This is the first equation and this is the second equation. Now this will be a1, a2, this is a2, this is b1, this is b2. Okay, this is c1, this is c2. So a1 is 2, b1 is coefficient of y, which is plus 1, c1 is minus 5, and a2 is coefficient of x in second equation, which is 3, b2 is coefficient of y in second equation, which is 2, and c2 is minus 8, constant term in second equation. Okay, Yes, we have to check first that these two pair of linear equation have solution or not. So to compare it, what we have to do, we have to know about the solution. What we have to do, we have to compare the ratios of a1 a2 and b1 b2. See, a1 upon a2 is 2 upon 3 and b1 upon b2 is 1 upon 2. So a1 upon a2 is not equal to b1 upon b2. In such cases, equations have unique solution, so it will have one unique solution. Okay, now we have to solve it by cross multiplication method. How we'll do? See, I have told you, we will write the variables and constant like this: x equals to y equals to 1, y1 plus 1, because we have written this equation in standard form. Okay, see, next, for denominator of x upon coefficients of y, which is 1 and 2, okay, and constant terms, which is -5 and -8. So x upon b1 b2 c1 c2. Okay, now for y, this you will take as it is here, c1 c2, and coefficient of x 2 and 3. Okay, for constant term, coefficient of x in both equation and coefficient of y in both equations. Okay, now you will cross multiply it. 1 multiply -8 minus 2 multiply -5. Okay, denominator of x. Now denominator of y, -5 multiply 3 minus -8 into 2. Now denominator of this constant term, 2 into 2 minus 3 into 1. Okay, now see, x upon -8 after cross multiplying, minus 10, okay, is equals to y upon -15 minus -16 is equals to 1 upon 4 minus 3. So after solving simplifying this denominators, will get x upon -8 plus 10 is equals to y upon -15 plus 16 is equals to 1 upon 1. This is after this you will get x upon 2 equals to y upon 1 equals to 1 upon 1. Okay, now to get the value of x, what we'll do, I have told you, compare this fraction with constant term. So x upon 2 is equals to 1 upon 1. X upon 2 is equals to 1 upon 1. We will get x equals to 2. Now to get the value of y, we'll compare these two fractions. So y upon 1 is equals to 1 upon 1. So we'll get y is equals to 1. So this method was cross multiplication method to find a solution of pair of linear equation. Okay. Now we'll do some more questions of the same exercise. See, question number 2, first bit we'll solve. For which values of a and b does the following pair of linear equation have infinite number of solutions? Okay, see, these are the two equations, 2x plus 3y equals to 7 and a minus bx plus a plus by is equals to 3a plus b minus 2. In first equation, a1 is 2, b1 is 3, c1 is 7. Okay, and in second equation, this is a1, this is b1, and this is c1. Okay, in terms of coefficients and constants of variable, we are taking a1 a2, b1 b2, and c1 c2. Okay, see, first of all, what we'll do, we will write this equation in standard form. So 7 will become -7, and after transposing this to LHS, and this expression will become minus after transposing this to LHS. So we have a1 is equals to 2, b1 is equals to 3, c1 is equals to -7, and a2 is a minus b, and b2 is a plus b, and c2 is minus in bracket 3a plus b minus 2. Okay, see, we have to find values of a and b. Values of this a and b we have to find when these pairs have infinite number of solution. And we know the condition when some pair of linear equation has infinite number of solution, if a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. Okay, so for equations to have infinite number of solution, which we must have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So this is a1, this is a2, this is b1, this is b2, this is c1, this is c2. We will equate this after comparing the ratios. We'll compare first term with third term, means first fraction with third fraction. After comparing, or you can compare these two also. any two fractions you compare, you will get some equation. Okay, by comparing first and second fraction, you will get 2 upon a minus b is equals to 3 upon a plus b. Okay, see, after simplifying it, it will be 2a plus b is equals to 3a minus b. Opening the bracket, you will get 2a plus 2b is equals to 3a minus 3b. Then it will be like terms you will add or subtract. So 2a minus 3a is equals to minus 3b minus 2b. Okay, so here a is equals to 5b. You will get first equation, or you can say relation between a and b. Now you will compare other two fractions. Okay, this is the second fraction, and this is the third fraction. Okay, so after comparing this will be transposed to our LHS. Then 3 multiplied by this, and this will be transposed to RHS, so 7 multiplied by this. Okay, after opening the bracket, you will get 9a plus 3b minus 6 equals to 7a plus 7b. Now you will add or subtract the like terms, or transpose each and every term to LHS. You will get 2a minus 4b minus 6 equals to 0, and this will be the second equation. Now you have relation between a and b, so it is very easy to use substitution method to solve this. Okay, so you'll put a is equals to 5b in this equation. You will get b is equals to 1 and y is equals to 5. Okay, now in the next video of the same exercise, we will solve some word problems. Okay, I'll not give complete solution. I'll only explain how to form equations, or how to represent the situation algebraically when word problem are given. Thank you.